Now the second video for the first model, and in the previous video I explained about cylinder and the arrangement of cylinder and liners, that is dry liner and the wet liner. Now the one more very important part of the IC engine is piston. So piston is a reciprocating part of the engine and converts combustion pressure in the cylinder to a force on the crankshaft. The pistons are slightly smaller in diameter than the cylinder bore. The space is provided between the piston and cylinder wall is called clearance. This clearance is necessarily to provide space for the film of the lubricant. So pistons are made of the aluminum alloy, cast iron, cast steel, chrome, nickel, and aluminum alloy pistons are used in a modern automobile. So this is what it is, the piston we are having. And now the diagram for the piston. So this is the line diagram for the piston, you may observe clearly. So the integral part of this pistons are, first one is the head crown. So this is what it is, head crown. Rings they are provided here. So grooves, ring grooves. So around the piston they provided grooves, and supporting web. Here is the supporting web, and oil holes. We are having here oil holes in the piston, so that we can provide lubricating oil to the cylinder surface as well as on the surface of the piston. And piston pins are provided, so skirt portion of the piston. So this is what it is about the piston. So now typically IC engine piston shown in the figure, the piston is almost has the shape of the inverted bucket. So inverted bucket. So the top portion of the piston is called head or a crown. In some engine, the pistons may be specially designed to form desired shape of the combustion chamber. At the piston top, few grooves are cut to accommodate the piston rings, and bands left between the grooves are known as skirt. So skirt is provided with the bosses on the inside to support the piston pin. The aluminum alloy pistons have the following advantages over the cast iron piston. We have the different metals, so with the help of those metals we can design, or we can prepare the piston. So those are here we have two types. So one is the aluminum piston, aluminum alloy piston, and cast iron piston. So what are the advantages of aluminum alloy? So lighter weight, allowing higher RPM. So with the help of, if at all piston is made with aluminum alloy, so it will be having less weight, and has higher thermal conductivity. So thermal conductivity of aluminum is higher than the cast iron, so it will give us the better thermal conductivity for higher compression ratio. So likewise we have two types of metals which are used here to Now next essential part of the engine is connecting rod. So connecting rod, so what is connecting rod? I will explain now. So this is the diagram for the connecting rod. Here we are having big end bearing and small end bearing. So how it why it is required, and what is the construction of the connecting rod, we will discuss now. So connecting rods are used to connect piston to the crankshaft. The upper end of the rod oscillates, swing back and forth, while the lower end or big end rotates. So you may observe here, this is the big end. Okay, so lower end or a big end rotates or turns. So it converts reciprocating motion of the piston to the rotary motion of the crankshaft. So you already know this connecting rod will be connected both crankshaft and the piston. The upper end of the rod has hole through it for the piston pin. So there is a piston pin, so that we can connect with the help of piston pin with the piston. The lower end must be split type. Okay, lower end must be split type. So here you may observe split type it is. The combination of axial and bending stress acts on the rod in operation. The axial stresses are due to the gas pressure and in the cylinder, and the inertia force caused by the reciprocating motion. Bending stresses are caused due to the centrifugal effects. Connecting rods are manufactured by the casting and forging process. Okay, you know about this casting and forging process, which will be there in your one more subject. So that is manufacturing process subject. So there you know about this. So with the help of casting and forging process, they will be um, prepare or made this connecting rod. The rod has an I-beam cross section to provide maximum rigidity with the minimum weight. Generally, rods are made by the drop forging of the steel or duralium, and also cast from the malleable cast iron. So likewise, we are having here connecting rod. So now the crankshaft. So very important part is crankshaft. So this is the diagram for the crankshaft. You may observe here. So it consists of very important. It is the thrust bearing, and there is a shaft, and here this one is the flywheel end. Crank pin we are having here. Crank web it is there. Main bearing journal. So this is the main bearing journal. Oil holes are provided for the lubrication, and extension for the timing gear or sprocket and pulley from end. This is the front end and this is the flywheel end. So that is what it is, the crankshaft. Here major parts are the main journal bearing and crank pins, crank webs, counterweights, oil holes. The crankshaft is held in the position of the number of main bearing, and they form axis for the rotation of crankshaft. Their number is always one or one less than the number of cylinders. So whatever the cylinders we are having, so not equal to that number of the cylinder, it should be more than cylinder, whatever more than one of those number of the cylinder, or less than one of the cylinder. And now here journals for the connecting rod. Okay, the crank pins are the journals for the connecting rod. Big end of the big end bearing are supported by the crank webs. The distance between the axis of the main journal and the crank pin center lines is called crank through. Oil hole are drilled from main journal to the crank pins through crank webs for the lubricating big end bearings. When the engine is turning due to the rotation of both crankshaft and connecting rod, the big end, each crank pin will be subjected to the centrifugal forces. This will be tend to bend the crankshaft to avoid the counterweight are used. To counterweights are formed as an integral part of the crank web or may be attached separately as shown in the figure. So this is the figure. So likewise we are having, an engine is running due to the rotation both crankshaft and connecting rod big end, each crank pin will be subjected to the centrifugal force. This will be tend to the bend of the crankshaft. To avoid this, counterweights are used. Okay, so there is a counterweight, so these counterweights are used. So this is the one more diagram we are having here. So two diagrams for the counterweights. One is integral and another one is the attached separately. So this is the integral type of counterweight, and this one is the attached separately for the crankshaft to avoid the bending due to the centrifugal force acting during the operation of the engine. Now moving towards the one more very important part, that is the walls. The walls, okay, directly you know about the wall. So that is here each engine cylinder has two valves. However, some specially racing engines having the 4 valves per cylinder. The air fuel mixture is admitted to the engine through the inlet valve, and burn gases are escape from the exhaust valve. So that is what we are having here, two types of valve, inlet valve and exhaust valve. Inlet valve is used to here fuel mixture has to enter into the cylinder with the help of inlet valve, and after combustion the burning gas will be goes out of the engine through the exhaust valve. We are having here two types, that is the poppet valve and the sleeve valve. And the very important is poppet valve is universally used for the automobile engine. So for the automobile engine poppet valve is required, so we will concentrate on poppet valve. Its name is derived due to its motion of popping up and down. So that is, so there is a reciprocating motion of the valve, so it will be move up and down, so popping up and down, so that's why it is known as what it is, poppet valve. As the same shape resembles a mushroom, so it looks like a mushroom, so this valve is also called as mushroom valve. It consists of head, stem. It is simple in construction and self-centering seal ring. Efficiency maintenance is much easier with a poppet valve. So you may observe the diagram of poppet valve. So this is what it is, the poppet valve. So poppet valve, so you may observe here, so it consists of a head here, so this is the stem of the valve. Okay, so that's why it looks like a mushroom, so that's why it is also known as what it is, the poppet valve. So this will be poppet up and down, so that's why it is known as what it is, poppet valve. So here also we are having two types. One is the regular poppet valve, and one more is the sodium cooled poppet valve. So sodium cooled poppet valve. So definitely the temperature will be increased, there are heat will be produced inside the engine, so we need to control the temperature of the valve, so that it will be withstand with a longer time, so that's why, so cooling process is required. So the regular poppet valve is redesigned like this, so that is which is showing in the figure, that is figure B, the sodium cooled valve. Here inside the valve they provided one hollow stem, they given here hollow stem, and sodium is used here, and which is kept inside the poppet valve, which is used as a cooling agent. So whenever temperature increases, so what happens, you may observe here, okay, right. So you may observe, so sodium cooled valve, it is nothing but sodium is partly sodium is kept inside the hollow stem of the valve. So it is filled, the sodium is partly filled, about 40% volume of the stem, and with the sodium mixture, sodium conductivity of the metal melts at the 105 degrees Celsius. It is an liquid state operating temperature. When the valve is in operation, up and down movement will be taken place. So when the valve is moving up and down, so that time, so sodium also inside that valve will be moving up and down, so that what happens, it will be receive heat from the what is valve, and it will be reject that heat towards the water jacket. So likewise, so sodium valve is used for the IC engines. Okay, so this is what it is about the valve. Okay, next one more video I will do for the next part of the first model. Thank you.